Welcome back to Genetics in the Paddock with Emily. I'm your host, Emily Johnston, and I'll be taking you along on my journey to learn about all things genetics in extensive livestock. Last season, we explored the foundational aspects of genetics. We discussed everything from basic genetic principles to practical applications on farm. This season, we're kicking it up a notch. Today's guest is Sam Clark, who is a professor in Quantitative Genetics at the University of New England. Some of the topics we're going to discuss include reference datasets, genomics, breeding program design, and more. This is an episode I can guarantee you'll want to stick around for, and one you'll enjoy. So with that, let's get into it. Welcome back to another episode of Genetics in the Paddock with Emily. Today I'm joined by Sam Clark from the University of New England, and I'd like to say a big thank you to Sam for sitting down with me today to have a bit of a chat about some topics within genetics.
Hey Emily, thanks for having me.
Thanks Sam. So let's just jump straight in. Give me all of the juicy bits, like tell me who you are, what you're doing at the University of New England, and a bit about your backstory.
Oh, okay. Thanks, Emily. So, of course, I'm Sam Clark. I'm a professor of animal genetics at UNE, at the University of New England. I've been here for the last 12 years, so in an academic teaching and research role since 2012. Before that, I did my PhD in quantitative genetics and have been working in that space. It's an interesting space because you do a lot of training, so teaching, and also a lot of research. So you have quite a bit of a juggle between those two components of my job. So in terms of the research component, what we've been up to, we've got a lot of research happening here at the moment, ranging from projects that are looking at methane in both beef, cattle and sheep. Then we have other projects looking at meat quality in beef cattle, with big global projects with Ireland and the USA. We also have projects that are trying to link knowledge, so like training projects with UQ and a group of other universities, trying to link plant breeders and animal breeders, because for a long time those groups of people have been quite different, and we've used a lot of the same knowledge to get to similar spots, but we can share a lot of information. And so we have a cool project to try and kind of facilitate that sharing. And then, of course, there's the teaching component that is a huge part of my role that I really like. We teach undergrad students within our agricultural degrees, so the Bachelor of Rural Science, Bachelor of Agriculture, Agriculture and Business, and Animal Science. And then we have a group of PhD students that we're training essentially to become the next generation of researchers. And so it's a nice diverse role. I mean, it's a lot of fun actually, having lots of things going on. And I guess that's a bit of a start. You also asked, didn't you? You asked a bit of the backstory about how I came to here. And in terms of backstory, like I grew up on a farm. I'm from the New England, here in New South Wales as well. I have always been interested in agriculture. I probably, when I look back on it, never really thought that I'd end up in a space working as a professor at a university, doing teaching and research and engaging with a global community of researchers. I probably thought I'd end up being a farm worker or back on the farm or a shearer. I spent a bit of time doing that after school. So I was quite applied, quite practical, loved sport and those sort of things, and didn't really get involved in academic pursuits until really halfway through university. And so it's been quite a journey, because I was quite applied, didn't put probably enough focus on learning school-based stuff of the academic sense. But then I actually did a Bachelor of Rural Science here at UNE, and at the beginning of my third year we had a genetics subject that I clicked with. The reason I clicked with genetics was I started to see that a lot of advice that's given to farmers is about how do you improve the mean performance of a group of individuals. So can you feed them something else and the mean will change? Can you give them some health product and the mean will change? And what I saw with genetics is, wow, there's this world of variation. Mm-hmm. Everything is actually pretty different. The mean is, there's a lot that are around it, but there's so much variation from that mean. And during that unit, I started to realise that, hang on, you can actually optimise a system with this variation. There's some cool natural processes that happen around mating that recombine all of genetics from parents to make new stuff. And how we design these new things, whether it be plants or animals, can be really, really powerful. And so it really resonated with me in that third year unit. And that was really the beginning of the journey in genetics. And then it's gone from doing undergrad. I ran away and worked for a bank for a little while and then came back because I still like numbers and quantitative stuff. And then came back, did a PhD, and I guess here I am. It's kind of a chance pathway that I've ended up in a space that suits me, which is good.
Yeah, that sounds really cool. Thanks for sharing your story there, Sam. It sounds like I love hearing, especially when people have that moment where it clicks, because a few people have mentioned that to me when they've, spoken about their backstory and how they got into genetics. And it's so interesting that a lot of people can pinpoint the moment where they're like, yep, that sounds like something that I want to be involved in. So yeah, that's really cool. And it sounds like you guys are involved in a lot of different research projects and collaboration in your role. So I guess within that, what sort of area of research do you find yourself most drawn to, or do you have a bit of a passion topic or subject within the realm of genetics that you just love?
Yeah, of course. The cool thing about being an academic in university is you still have quite a lot of flexibility to work on lots of different subjects. Through my PhD, I worked in topics using genomic information to predict breeding values and how to design data sets. We call them reference data sets or reference populations to actually give good predictions to breeders to allow accurate selection of their animals or selection candidates. And so I worked in that in my PhD, and then I've kept that kind of theme of breeding program design linked with genetic evaluation all the way through. And I really like that theme of designing the breeding program, but also understanding how breeding values are estimated and how we can improve that, especially around the collection of novel traits, so new traits, things like methane, meat eating quality, even other traits that we might have score-based measures, how we can improve those, like structural correctness in livestock as well. So I think I've really focused on this data generation to inform breeding values and genomic breeding values. And I like that space because you're always learning from the new traits that you want to record.
And it sounds like there's a lot of room in there to, find new traits or pick up something based on, how the industry is evolving or different needs or market requirements or that sort of stuff. So it sounds like there'd always be something to work on and, something that's popping up that's new and would be probably exciting, I can imagine. So before you mentioned reference data sets, and can we just talk a little bit more about what exactly that is and why they're important to achieve accurate genomic estimated breeding values?
Yeah, okay. So reference populations, it's a term that kind of evolved when genomic breeding values were first being invented and researched. But really, it's something that's been around for a long time. A reference data set or a reference population is purely animals that have phenotypic performance with some knowledge of how they've been managed and then a way of linking them together. In traditional pedigree-based evaluations, we linked animals together with pedigree because we know who's related to who, and over a long period of time, if you record who's mum and who's dad, then you can link animals together. Now, with the advent of genomic information or DNA test information, we can now link a wider group of individuals without having to have tracked that knowledge over time. So there hasn't had to be a person tracking a pedigree. We can now say, well, you share this much of your genome with another individual. And so that means that this reference population used to be all animals with pedigree and a phenotype and management known. and all the breeders that may listen to the podcast will have recorded a bunch of information. They essentially are the reference for genetic evaluation. We started to focus more on it when we started to have this flexibility of recording wider groups of animals to inform breeding values. And so now it's kind of been termed just for genomics, but it's really for everyone. So if you have single-step genetic evaluation systems where you have both genomic information and pedigree information, all animals with phenotypes, management information, genotypes and pedigree are part of the reference. They're any animal that's informing breeding values for the animals you want to select. So I think it's good to point that out, because it's important to know that every piece of information that's recorded in an evaluation system is used to inform this reference and inform breeding values for animals you want to select.
That's a really, really cool, I suppose, concept, especially as you were saying that people who are submitting that information become, well, the animals that are submitted become part of the population as well. And it sounds like based on that, the reference population is kind of always getting updated based on what's happening on ground as well?
Yeah, definitely. So reference always gets updated with whatever anybody's recording. It's usually a bit easier to update easy to measure traits. So if someone can record weights quite accurately and quickly, or scan their animals, or potentially even birth weigh their animals, which is always a bit tricky too, you've already got a reference for those. So most of the time in the research sphere, we're focusing on traits that are hard to measure or measured late in life. And so those harder to measure traits, then like the name suggests, not everyone can actually record them. Not everyone can afford to record them. And that's where there's kind of this kind of market failure in a sense, that if we want to select for those traits, then we have to record them somewhere. Someone has to, and we have to link them to selection candidates using DNA. And so that's where a lot of reference population projects have been born, in a sense. So you've got the resource flock in sheep. We've had Southern Multibreed project with New South Wales DPI in the south for southern beef. There's been some northern genomics work and repronomics work in the north. And those projects are really centred around these harder to measure traits, because we still want to have accurate selection and nice balanced selection for the breeding program for those traits too.
So in the research space, like there are a lot of, it sounds like there's a fair few projects that are capturing this sort of data for the harder to measure traits specifically. So how do you determine the optimal size for a reference population, especially considering factors like genetic diversity and just, an effective population size?
Yeah, okay. So diversity is an important thing because we want evaluations to cover everyone. But to be honest, at the start of a project, you have to make a choice. When you have no data, the value of new data is really quite high. And you want to try and target individuals that will be relatively closely related to the ones you want to predict. That's when the reference population is small. Okay, it's small, it's evolving over time. We might get a few thousand records. So the close relatives we can predict quite well. The distant relatives, it's much more challenging for a small reference population to predict. So that's why as populations get bigger and bigger and bigger, we start to do a better job at the ones that are distantly related, because they end up having more and more and more little chunks in common with that reference population. So there's no golden number. There's no how big should a reference population be for this or for that. It's more at the start of the recording journey for a new trait, it'll be small, so you have to target groups of individuals that will be closely related, but also related to the ones you want to predict. Mm-hmm. And then as it gets bigger, you get more flexibility about the animals you can predict. And the hard part of it is it's kind of like something you're always grasping for in the future. It never ends because the population always changes. It's like recording in most breeding programs anyway. You can never stop recording stuff. It's it was often, I guess, sold in a sense with genomic technologies that you'd be able to record a group of animals and then never have to record ever again. That hasn't come about. That hasn't been the way it's gone. We still have this thirst for data. The way to handle that is that there's a lot of work always in how can we automatically collect that data? How can we learn from industries that do that as part of management? Industries like the dairy industry that record milk traits every day, and it kind of comes with management. Can we make new tools to record hard-to-measure phenotypes that kind of link with management too, to bring down cost and get more and more data? Yeah, so really there isn't a golden number. You have to make sure that you've got a big enough reference population that you can make some accurate predictions for some animals, and it just evolves over time from being focused on close relatives at the start to opening up and having wider predictions as you get more and more animals.
Sounds like an incredibly powerful tool, especially like when you were saying, bits and pieces from each animal and, improving accuracy as well. I found myself visualizing it too, which is, it seems just like a really cool and really powerful concept. So I guess for breeders who are looking to implement genomic selection in their breeding programs, what sort of challenges do you think they might face, and are there solutions to overcome them?
There's always challenges. It's a really good question, because maybe if we look at it from where you sit in a breeding program, in a sense, so the needs for someone that's buying males, rams, or bulls will be very different to someone who's at the top of a nucleus that is creating bulls and rams for other people to buy, or to again breed the next generation of bulls and rams. And so those different classes will have different needs. At the bottom end, in that commercial production sphere, the space for genomic technologies is really around, can we more accurately select the right bulls and rams, so the right males? There's other opportunities for commercial female prediction. So can we select young heifers better than just on weight or productivity characteristics that are easy to record? So there are some tools around in beef cattle and in dairy cattle, clarified and heifer select type tools that help commercial producers find new females. The important thing to note with those tools is that you still inherit your genetic progress from the bulls and rams you buy. And so if you have kind of a hierarchy of decisions that you make around what genetics do you import into your system, most important one is still what genetics do you buy? Because bulls and rams have a big footprint on production. And then a commercial heifer is important to an individual producer, but they only have a small footprint compared to the bulls you buy. So if you want that extra bit of cream on top, you can think of those heifer selection and female selection tools as a bit like the cream on top. But don't forget about, like the old meat and gravy, which is the selection of the males that you import into the system. So that's a commercial system. In terms of the nucleus system, let's think of the nucleus as groups of breeders who breed sires of sires. So bulls that are going to be the sires of the next generation of bulls. Well, in that part of the breeding program, it's really important to have accurate selection. So it's all about this thirst for accuracy for all of the traits that are important in your breeding objective. And so for those people, it's around, should I record? Should I also take a genotype? Because you'll also be part of the reference population. And it's how do you maximise accuracy of selection for all of the traits that you're interested in? And how do you maximise accuracy of selection for your total breeding objective or your index? So in that sense, it's about how do you contribute to information for the breeding value, and then how do you just select the top animals for the next generation. Now that second one is core to every breeding program. You want to try and select the top animals, of course, but you probably need to still manage diversity. as well, because for long-term genetic progress, you don't want to kind of just use one sire and have a bottleneck of diversity. So other tools like mate selection can be really helpful to that group of individuals, and using genomic information in mate selection can be quite powerful too.
Thanks for that, Sam. That was a whole chunk of really, really good information, and you highlighted some really great tools available as well, which I think is important because it sounds like these are huge decisions to be made and potentially could become quite complex or confusing at times as well. So yeah, thank you for that. And I guess maybe my next question might be another one of the, there's no optimal amount or size, but how many animals should you be genotyping?
That's a good question. It's one that always comes up, Emily, especially in early times where there was this thought that you'd have this reference population, never have to record again, and you could just genotype animals and Bob's your uncle in a sense. But it's kind of got a bit more complicated, I guess, over time. So let's think of those two groups of people again. You've got your commercial producers and you've got your nucleus breeders. Sometimes there's some multipliers in between, but let's just focus on those two. If you're a commercial producer, often you can get some good bang for your buck by essentially genotyping a proportion of your selection candidates. So sometimes we can say, and some good papers that are out there around how can you get the best value for genomics would be, can you select or genotype fewer numbers? Can you select 50% or 80% or 20%? And after a bit of modelling, you could work out, and we did with some colleagues, so Julius van der Werth and Tom Grenlees as part of his PhD, we worked out that you can essentially genotype 20% of the animals for 80% of the gain. But of course, you can only genotype 20%. You miss out on animals. So if those 20%, that is the difference between 100% and 80%, matter to you, well, then of course you've got to genotype more. Mm-hmm. Okay, so you don't get 100% of the gain. The main way to get 100% of the gain is to genotype everything. Yeah. Now, if the cost of genotyping is really high, then the overall value, the 80-20 rule, is quite good. Now, if the cost of genotyping is very low, well, then the value proposition for genotyping everything is much, much more powerful. So you go, okay, well, actually, it doesn't cost us much. We can get that extra 20% of gain from that. In the nucleus, where you tend to be recording animals as well as genotyping animals, there's the two value propositions. One is to be part of the reference so that you are automatically linked to your genomic predictions that make them accurate. The other is, of course, selection accuracy. And you still get quite a lot of selection accuracy from genotyping individuals. So in that nucleus sense, and if genotypes are relatively cheap, genotyping all animals is quite valuable for selection. But it's still a balancing act in a sense. If genotypes are expensive, then it makes the value proposition for them becomes harder to make. Whereas if they're really cheap and it links you to lots of information, then that value proposition is easier to make.
Yeah, that makes sense. Definitely some things to consider there, Sam.
Yeah, the value proposition is a good one because I think it's easy to forget that breeding programs are essentially a business. So you're just selling genetics and creating new products every time. In plant breeding, we often think about varieties as new products. What's the new product that we're going to release to market? In animal breeding, there's often a continual change, and so people don't often think the same way at times. But I think if you do, then you can really start to think, well, what's the cost of implementing a new thing in the breeding program and what's the value? And if you think of it always as this product that we're putting into a marketplace, it becomes quite easy to visualize how it links to business.
Yeah, that's actually a really interesting way to put it. And I haven't heard that before, but it makes a lot of sense. And I feel like that would be something that would resonate with people or just like click, which is important when you're trying to explain something as well. So we spoke a bit about earlier in this episode that you're involved in a fair bit of teaching as well. And I guess you've done a lot of research and you have a lot of things to share. So how do you integrate the research findings into your teaching curriculum? Or is that something you do? Or how does that integrate?
Yeah, that's a good question. I really like the teaching part of my job. I've, over the last 12 years, taught a couple of thousand people about animal breeding and genetics and plant breeding and breeding programs. Maybe I think of it as a long-term investment, that if you only need a few people to be really interested in the concepts of genetics, that you're training the next generation of people to ask questions of the data that we generate, ask questions of how we can improve things. And so that linking with students is really good for that. It also, I've been watching a TV show lately, I was put onto it a bit late. I'm late coming to the party for this one. But if anyone is following and they have watched the Ted Lasso TV series, there's a really good comment that resonated with me in that TV series. A little bit of background about the TV series is that essentially an American comes across to manage a football team, soccer team in the UK. And he has no skills to do with football or soccer, but has a lot of skills around managing people. And he has a moment there where he has a good one-liner, and I'm a sucker for a one-liner. In a sense, he makes the comment of be curious, not judgmental. And I think that really fits with teaching. It fits because if you teach people to always judge a system of, this is what they're doing wrong or this is what they're doing right, you kind of set up a culture of being just overcritical of what people do. Whereas if you're curious about a system, you become better at questioning that system. So you ask why. Why do you do this? Why do you do that? What could you do to improve it? And that curiosity, I really think, is an important part to teach people. And then that's an awesome way to link in with research, because we ask questions, why do we do this? What could we do better? And to integrate all of our research findings into undergrad curriculums, which of course we do, we're a university, that's what we're paid to do in a sense, we can encourage students to even question what we do. We're doing research in methane. Why? Why would we be working in methane? And once you start to question that, you say, can you get efficiency gains? Can you get climate gains? How could we go about that? What are some limitations? And so having that questioning, rather than just saying, methane's just produced from a cow and it comes from grass, which is a judgment, you start to do a much better job at figuring out how can we improve a whole system. So I really like that. I like that link to undergrad teaching and this questioning that we try and teach people, I guess.
Yeah, cool. I'm sure you probably get some interesting and curly questions through teaching as well. Has there been any memorable moments where you can think that someone's questioned, either a piece of work or, I don't know, just a research finding, and you feel like, actually, I'm not sure, or maybe I'll think about that a bit more. Has there been anything that's really challenged what you've said that's made you kind of go home and think about it?
I think there's been a lot of those moments where you think, hang on, how does that work? Moments that resonated with me over the last few years have been, I've had students question why we work on methane. That's a great one, because there's a lot of different perspectives in society around why we do that, and I still get thinking about why, in terms of, can we improve efficiency? Yes, methane's a lost energy source. Can we also use stories around methane and what they do in a production system in terms of cows and sheep to describe how they fit in the system, that they're not creating anything in a sense, they're just turning grass into meat that we eat, and there's a process around it. In terms of genetics around breeding programs, I've been working quite a lot in resilience and having students work in resilience and how to have robust animals that can withstand different environments. And so I often used to think, if we just select for productivity, we'll get healthy animals anyway, because the big ones will be healthy. Whereas we've found lately with a lot of students' work that often that may not be the case. Sometimes there are animals that are more resilient to change that are in the middle of the group, not just at the top. And so having that bit of questioning as you go really, really helps. They'd be the main ones that I link. But sometimes it's about understanding, for me, for a personal experience. So let's say if you're teaching a new topic, you're teaching index selection, how to generate bioeconomic models for generating indexes for industry and stuff. Often you'll get a question, you think, oh, hang on, do I exactly know how that works? And you have to go back and really learn the process behind it. And so I find, from a selfish point of view, in a sense, that teaching also highlights what I know and don't know and what I need to improve to be able to be a good teacher and to be able to accept what you do and don't know and always go, oh, well, if you don't know, go and find out if there's an answer. If there's no answer, then that's cool, because that becomes a bit of a basis for a research project in a sense. Yeah, it's that awesome link that we get.
Yeah, I really like that. I like the idea of, as well, challenging people to think outside of the box, because I think that some really interesting conversations or discussions can really generate from that as well, rather than people not thinking about it at all and just accepting it as it is, but not voicing the opinions that they have or thoughts. So yeah, thanks for sharing that, Sam. That's really cool. What are some of the biggest challenges that you face as both a researcher and a professor, like as a combination? Maybe it ties into what we were just talking about then, but I'm interested to hear if, working in those two roles, if there's, a challenge that exists between the two, because they're quite similar, but at the same time, I imagine quite different.
Oh, they are very different. In a research sense, you have a goal, you have an aim, you work through the whole scientific process of having a hypothesis, testing that hypothesis, and understanding the results of those tests. So it can be quite fixed in a sense. The challenging thing for me personally, though, is the world is an awesome place, and there's opportunities everywhere. Okay, and maybe I have that personality that really likes to work with different groups and different ideas and different people. The challenge I have is time. That's probably my biggest challenge is managing this juggle of putting only a proportion of my time to research and a proportion of my time to teaching, but I want to do both really, really well. And when you've got that split in time, sometimes it's tricky to know when to say, oh, actually, I should hand this over to other people, or I should get some help with this. So early on, I had probably a desire to do a lot of things myself. And whether it was teaching people, I wanted to do it myself, doing research, I wanted to do it myself. And I figured out quite quickly that that's not very sustainable, and you become a bit closed in your ideas. The best way is actually to share, to collaborate, to work with lots of people. Means that you get a really diverse experience of life. You work with a lot of different students, work with a lot of different researchers and organisations if you learn how to share. And like I said, I'm a sucker for a one-liner, but I've probably moved away from trying to be the researcher that can do everything to the researcher that can work with everyone. And I have this little saying that I think we should collaborate rather than compete as researchers and teachers. And if we have that mindset, that if you can learn from so many different people, and you can actually, when you're too busy, give it to someone else and work with them rather than just try and look after it yourself, I think you'll learn so much more. You start to realise that the world is a really big place. We don't just work in a national community of undergrads or university systems in Australia. There's people all over the world tackling very similar problems to what we do here, and they've all got different perspectives because they've had a different journey to where they are now. And if you can start to learn from those perspectives, wow, life is really interesting. And being a researcher is really interesting. Being a teacher, you can then start to inform and help the different people learning about genetics from many different perspectives rather than just the one of your own.
Yeah, no, that sounds really nice, Sam. And so you were just saying that you've done like a lot of collaboration. So I imagine a lot of that, or some of that, would be international too. So have you had any kind of conversations with people internationally, and it's helped shape or change of perspective that you've had just because they're looking through a completely different lens?
Yeah, so we've got a lot of international projects at the moment, which is really cool. I like living in a country town in Australia, in the north of New South Wales. Armidale's not a big place, about 25 to 30,000 people, but the world is a big place. And when you realise that, you start to be able to work with people. So the projects we have in understanding meat quality in beef cattle, so beef, with Ireland and the US, that's really interesting because their production systems are so different. So in the US, there's still a quality focus, but there's a lot of beef, okay? So, and they can go to a variety of markets. It's still dominated in the south. In Australia, you have Angus, and that links pretty well with the US production systems, some grain feeding to finish animals. But then you have across in Ireland, where it's a very different system, dominated by European breeds, so Limousin, Charolais, those types of animals that grow quickly, turn grass, which in sometimes a year in excess, they turn grass into beef quite quickly. And the learning about those production systems has been really cool, around what's happening in Ireland, what's happening in the US, what happens in Australia. We also link in with European groups. So over at Wageningen, we have some collaborations as well within chickens, pigs, and those sort of things. So learning what happens in other industries is nice too, to see, I wonder what's happening over, how do we manage leg structure in turkeys? Mm-hmm. Can we use some of that same technology around sensors and cameras to help with leg structure in beef cattle, which that's cool to be able to take ideas from one system to be able to try them in another. So that'd be my value of the global collaborations, is just that learning and learning those ideas that other people have thought about that we can utilise here in Australia for our production systems.
That's amazing. I always love looking over the fence stuff. It's always so cool to see what other people are doing, especially when they're just in such a different world or such a different space to what we know. So yeah, I would personally find that really, really cool. And my favourite question that I always ask at the end of my episodes, which I'm going to give to you as well. So what do you think the future looks like in this space? I guess when we think, say, future, you can take it as far as you like. You can say 10 years, 20, near future, far future. I don't know. I guess I'm just interested to see what you think the future holds.
Yeah, okay. So that's a challenging question. It's always hard to tell the future. So don't hold me to it if things don't work out the way I think they will. So the future let me think in terms of research. I think research is always important. So I think the future is always to be curious. There's always going to be questions. No matter how good we think we are, we're never perfect. And so the process and the idea of having this thought of being curious and not judgmental, I think will always be there. So we've always got to question what we're doing. So I think in the future that becomes always more important, is, okay, what do we know now? What can we do better? Why, what, how, all of what we're taught in how to question a system. In terms of agriculture as a whole and agricultural research, I think going forward we always have to have this sustainability focus. I think sustainable production, whether it be for food or fibre or products that we get from both plants and animals, I think there's always going to be this focus on making it more and more sustainable, whether it's economically sustainable, environmentally sustainable. They're both got to go hand in hand, because if they're not economic sustainable, people won't do it. And so I think there's always going to be this link to sustainability, and in the future I think that becomes more and more evident. I think will impact breeding programs for our species that we work with. There'll be more of a switch to recording traits that are important to other things other than just productivity. Productivity will still be very important because we want to make more from less, but we'll also have other things being pulled into our breeding programs, whether it be disease response traits, so how well do animals respond to environmental stresses or disease health stresses. How do they respond to different environments? Can we have animals that perform well regardless of environment? Can they use resources that we have in an efficient way? Can we get more from less, essentially, as we go forward? So I think the switch will be we've been really focused on productivity for a long time. I think there's going to be more and more push to this sustainable model. And I think that's a good thing. Sustainable agriculture, we want to use and manage our resources the best we can. And I think that's a really nice concept about research for the future, and I think that'll become more and more important.
Yeah, thanks for highlighting that, Sam. I couldn't agree more. I think sustainability is going to be a big thing, and I think it's a good thing that it probably will be. As you said, it's kind of just protecting the resources we have, so it's always a nice idea that we're striving towards that. Well, I guess that's all the questions that I had for you today, Sam. So I'd like to just say a big thank you for sitting down and having a chat with me, because I know we spoke a bit earlier about, time being something where it's hard to figure out which bucket to put it in. So thank you for putting some of the time resource into the podcast bucket today.
Yeah, no worries. Thank you.
No worries. Thanks, Sam.
Okay, see you.
And that brings us to the end of this episode of Genetics in the Paddock with Emily. I hope you found our discussion as enlightening as I did. This episode was produced by the extensive livestock genetics team within the New South Wales Government. If you enjoyed this episode, please consider subscribing to our podcast on your favourite platform, leaving us a review and sharing it with your friends and colleagues. Your feedback and support help us grow and reach more people who are passionate about livestock genetics. If you have any questions, comments, or suggestions for future topics or people you'd like to hear on the show, please feel free to reach out to me on emily.johnston@dpi.newsouthwales.gov.au. Thanks again for listening, and until next time.